It seems like 1,000 years have passed. I can't believe I am still waiting. The sun is out. It feels like I'm melting. It's been 10 minutes already. This needs to change.
Hey, we have to go. It's almost time for class.
We can't give up yet. We have been in line for 10 minutes already. One chocolate flavor ice cream, please.
Chocolate flavor is in production. Please wait another 5 minutes. Try this.
The event in the trailer has actually happened. Basically, we had to wait for more than 10 minutes in the hot sun for just an ice cream. And then, when it was finally our turn, we were let down because the flavor that we wanted was still in the production process. So, that day, we ended up sweaty, late for class, and disappointed with no ice cream. Waiting in queue for an extensive amount of time is not a fictional problem. It is happening everywhere. For example, the Parabola stand at Chulalongkorn University. How it functions is a single employee would take the customer order, make the ice cream, and collect the payment at the end. At the rush hour of 12 to 1 p.m., it takes around 10 minutes to just buy an ice cream, which is insane. So, following the design thinking process, we first empathize. To find the customer's needs, we went out to buy Parabola's ice cream for ourselves, as well as conducting an online surveys for Jula's students. From our experiences and the survey, we learned that the queuing time at Parabola during lunchtime was way too long for pleasing its customers. While we wait in line, we would sometimes think to ourselves, is this ice cream really worth waiting for? Since the shop was outside, it was also really hot, making the queuing experience even more terrible. Lastly, sometimes the shop would run out of the flavor we want or are in the process of making it. Next, using the list of customer needs, we define our problem statements. How might we reduce the queuing time for the customer during the peak selling hours? And how might we improve the order and the payment system and make it more convenient? Then, we went and brainstormed as many solutions as possible. The idea that is most likely to succeed is to have a pre-order and online payment system, which inspired us to create Hyperbola, a fast-track retail system. Hyperbola will serve two types of users, the customers and the vendors. The customers are people who wish to buy an ice cream will be able to use Hyperbola to make an order, pay using online payment, uses rewards point system for discount, and see their previous order history. While the vendors are the people who will make the ice cream and serve it, will use Hyperbola to manage what flavors are available, manage the incoming orders, and see records and statistics of sales. In summary, we create a list of functional and non-functional requirements. What Hyperbola did to improve the system was remove the ordering process and the payment process. By taking out these two processes, it will allow the vendor to focus on only making the ice cream and fasten the process. For the prototyping, we first create a rapid prototyping class. Then, we use Figma to create the UI prototype design. In addition, we use Gantt chart, functional and structural model and design, ER diagram, and many more as a foundation of our web-based application. After we have a rough idea of how our application will look like, we started to make it a reality. We used HTML, CSS, and JavaScript to create the customer and vendor UI. PostgreSQL was used to create a database that would store all related information, such as the menu items and their price, onto the server. Additionally, Firebase was used to store all real-time queuing data. The IoT device that our project will use is a tablet. The tablet will be placed in front of the store to display the real-time queue. To test our system, we compared the waiting time of the customer. Before Hyperbola, The serving time of each customer is 15 seconds for ordering, 30 seconds to make the ice cream, and another 15 seconds for exchanging payment, combined for a total of 60 seconds each. This means that the waiting time is equal to 60 seconds times the number of people in the queue. However, with the Hyperbola system, we will be removing the ordering process and the payment process. This means that the serving time for each customer is only 30 seconds. So the waiting time for the customer is 30 seconds times the number of people in the queue. So how will Hyperbola benefit its user? For customers, it will decrease the queuing time, inform real-time information of product availability, and offer a cashless payment system. For the vendor, Hyperbola will optimize the procedure, attract new customers with the new lower queuing time, and increase sales and revenues. For Chulalongkorn University, Hyperbola will improve the student lifestyle as it will waste less time waiting in the queue. To wrap things up, Hyperbola, a fast-track retail system, is created from the knowledge we have learned in software engineering, database system, and ICE capstone. Hyperbola will greatly reduce the queuing time, as easy as snapping your fingers, just like that. Furthermore, this fast-track retail system can also be implemented at a similar shop, such as a coffee shop and other small food stand around Chula campus. With the help of Hyperbola, we believe that the students' lifestyle at Chulalongkorn University will greatly improve as they no longer need to needlessly wait around in long lines. Lastly, we truly believe Hyperbola will make Chulalongkorn University be one step closer to being a CU Smart campus. Please enjoy our demonstration and feel free to provide us with any feedback. Thank you. 3,000.